What are irrational numbers? We can easily define rational numbers. They are numbers which can be expressed in the form p by q, where q is not equal to 0 and p and q are integers. Numbers like 5, 3 by 8, minus 12 by 7 are rational numbers. Irrational numbers cannot be expressed in the form p by q. It's easy to think of numbers which can be expressed as p by q, but what kind of numbers cannot be expressed as p by q? We will see that later. But who thought of this? How did it come into existence? The Pythagoreans always believed that all numbers can be expressed in the form p by q. They believed all numbers had perfect values. Apparently, amongst the many Pythagoreans, there was one named Hippasus who said that not all numbers can be expressed in the form p by q. And this went completely against the Pythagorean worldview. They could not accept that there can actually be numbers which cannot be expressed as p by q. That angered them, and Hippasus was thrown overboard and drowned. But how did Hippasus prove what he said? We will see that in the next video. To prove the existence of irrational numbers, a right-angled triangle ABC was considered. The triangle was such that these two sides equaled 1, and the length of the hypotenuse was supposed to be found out. The Pythagoras theorem was used to get AC squared equals AB squared plus BC squared. AB and BC both equal 1. Substituting those values here, we got AC squared as 1 squared plus 1 squared, which equals 2. If AC squared is 2, AC will equal square root of 2. And Hippasus said that this is an irrational number. But why? How did he prove it? He used an indirect proof, and this is how he went about it. He said, let root 2 be a rational number. It implies that root 2 can be written as p by q, where p and q are integers which do not have a common factor. P by q is in its simplest form. How do we eliminate the radical now? To eliminate the root sign, we square both sides. So 2 equaled p squared by q squared. Transposing q squared to the other side, we got p squared equal to 2q squared. This gives us a very important result, and let's call it our first equation. What does this tell us? We know that 2 multiplied by anything is even. So the first equation tells us that p squared is even. It also means that p is even. That's because if the square of a number is even, the number has to be even. 2 squared is 4, 6 squared is 36. If the square is even, the number is also even. So let p be equal to 2a. An even number is always in the form 2 multiplied by something. Substituting this value of p in equation 1, we get 2a the whole squared equals 2 multiplied by q squared. A can be any constant. Opening the brackets, we get 4a squared equals 2q squared. Cancelling out the common factors, we get q squared equals 2a squared. Observe the right hand side. It's 2 multiplied by something, which means that q squared is also even, which means that q is also even. Wait, this gives us an interesting result. It tells us that p and q are both even numbers. This simply means that 2 is a common factor of p and q. If both are even, they will surely have 2 as their common factor. But look at what we assumed. We assumed that p and q have no common factors. So this is a contradiction to our hypothesis. Hence, root 2 is not rational, and numbers which are not rational are called irrational numbers. We can say that root 2 is an irrational number and cannot be expressed as p by q. Now we know that square root of 2 is an irrational number. If you use a calculator to calculate the value of root 2, you will get something like 1.4142135 and so on. This value that you get is actually non-terminating. It is never ending. Also, you will not find any pattern in the digits after the decimal. Hence, it's also called a non-recurring decimal. There's no pattern that occurs again and again. These kinds of numbers are called irrational numbers. Consider square root of 3 for instance. You will get its value as 1.732050 and so on. Even this decimal is non-terminating and non-recurring. So root 3 is also an irrational number. You can try calculating the values of root 5, root 6, root 7 or root 8. You will find that all of them result in non-terminating, non-recurring decimals. But wait, root 9 equals 3. This is a rational number. Yes, root 9 is not an irrational number. In fact, square root of any perfect square will be a rational number. But the square root of any number which is not a perfect square will always result in an irrational number. Here's the interesting part. If you know these 2 points well, you can even form an irrational number by yourself. Let's see how. We have to form a number which does not end and does not repeat any pattern. Something like 2.01001, 0001, 0001, 00001 and so on. Here, the number does not end and is also non-recurring. This means that there is no pattern that repeats forever. You can even have a number like 15.2349, 449, 4449, 44449 and so on. This is also irrational as it is non-terminating and non-recurring. Where does this concept help us? Say you're asked to find 2 irrational numbers between 1.23 and 1.25. Remember, 1.24 is incorrect as it's terminating. We need a non-terminating, non-recurring decimal. Yes, but we know that 1.24 is between these 2 numbers. After 1.24, we can start writing 01, 001, 0001 and so on. That's one irrational number between these 2 numbers. Again, let's write 1.24 and this time we write 02, 002, 0002 and so on after it. That's your second irrational number. So to find irrational numbers between 2 numbers, just write a rational number between them and then add non-terminating, non-recurring digits after it. All of us know what a number line is, and the numbers we see here on the number line are called integers. On the right side of 0, we have positive integers, and on its left, we have negative integers. Integers we are familiar with, but what about numbers like these? 1 by 3, 5 by 6, or -7/12? Each of these are numbers, but we don't use them as often as we use counting numbers. Such numbers are called rational numbers. But we need to define them well. We cannot say numbers like these are rational numbers. We say that they are of the form p by q. One number in the numerator and one in the denominator. But there are a few conditions we need to know. P and Q should be integers. We can have only integers in place of P and Q. And there is another important condition. Q should not be equal to 0. Why do we have the second condition? Say I ask you to calculate 3 divided by 0. What would be the quotient? 0 multiplied by what will give you 3? There is no such number. This value is undefined. So this is the basic definition of rational numbers.
It is a number of the form p by q, where p and q are integers and q is not equal to 0. There are many questions that should pop up in your head when you see this definition. What is the difference between rational numbers and fractions? Are integers classified as rational numbers? What about 0? How do we plot such numbers on a number line? And how do we compare two rational numbers? For example, if you're asked to compare 1 and 5, you could easily say that 5 is greater of the two. But what if you're asked to compare numbers like 6 by 7 and 13 by 15? How would you find out which one is greater? Don't worry about it. All these questions will be answered in our videos on rational numbers.